Morning again, everybody. So welcome to another revision session. Topic is inequalities and linear programming. Going on to a new topic tomorrow and Monday, new phase of the program. That phase of the program, we're gonna be looking at matrices, transformation, and vectors. That bank of topics is what we're gonna do next in that, and that's gonna be the second phase of this program. That's the next three topics we'll be doing: matrices, transformation, and vectors. All right, so finishing off with this topic today, this is revision. Those of you who attempted the questions, good. If while I'm going through it, you find that you made mistakes, you are required to redo the questions. Those of you who did not do the questions, you have to do them even after I do them. That is how it is. You have to do the questions even after I do them. Mathematics is not a watching somebody do questions topic or subject. It is a doing subject. You have to do the questions yourself. Even if you see somebody do it and you understand it, you still need to go and do it yourself. And that's why in each class, I say your first homework every day after class is to redo the examples I did on the board. Redo the questions I do as examples on the board. All right? All right, so what is on the screen here is the last class activity that we did in this topic. All right? We had two questions in the class activity. All right? The first one is a simple linear inequality to solve right here. And basically, you want to make X a subject. What I always say is that solving a simple linear inequality like this is basically almost the same as if you were solving an equation. X minus 3 equals 3x minus 7. So the same steps involved in solving this, in other words, making X a subject of this, is basically the same steps you're doing this. The difference with the inequality is what we have to remember is that if you have to multiply or divide with a negative number, you have to reverse this inequality sign. That is all. But the steps in solving this, the process in solving this to make X a subject is the same as solving that, the equal, with the equal. So if you can do this one, then you can do this one as well. Not a problem. Just remember that for the inequality, if you have to multiply or divide with a negative number, you have to reverse the inequality sign. All right, so let's go. I'm going to work through it quickly. And then after I'm finished doing this class activity, I'm going to do a couple questions. And I also want us to do one of those special ones. All right, I want to show you one of those special ones, just in case you get one like that. All right, I thought I had a notes up here. Let me get it. Right here. All right. So this is it, guys. This is it. So we're gonna be doing this question right here. All right. So let's write it out. It is x minus 3 less than 3x minus 7. I'm trying to make x a subject. So to make x a subject, you need to group the x values on one side. Right? You need to group all x terms on one side and consolidate them. So I'm going to do this question two ways, actually. I'm going to do it a way where I group the x values on the left side. I'm going to do it a way where I group the x values on the right side. Let me split the screen. I'm going to write the same inequality again. X minus 3 less than 3x minus 7. All right. So let's say first I'm grouping the x values on the left side for this one. It means that I need to get this x term over here. And I need to get this negative 3 over there. You only want expressions with the x in it on the left side. This is already there. So I'm going to write this back as x. This 3 is going to be gone over that side now, but I'm not going to put it there yet. I'm going to take this 3x and transport it over onto this side. And it's going to become negative 3x. The sign remains less than because I did not multiply or divide with a negative number. This negative 7 remains on this side, negative 7. And then this 3 comes over onto this side and becomes a positive 3. Positive 3. So you're transposing the same way as I said you would transpose this equation to make x a subject. Then now this is x minus 3x. This is 1x minus 3x, which is negative 2x. The sign stays less than, I did not multiply or divide. And this negative 7 plus 3 becomes a negative 4. So now we want to make this a subject. I have to get rid of this negative 2 that is multiplying by the x. So to get rid of that negative 2 that is multiplying by the x, I need to divide both sides by a negative 2. But remember now, because I'm dividing with a negative number, this sign has to be reversed. So let's write it out in red. I'm now going to divide both sides by a negative number 2. And because this number I'm dividing by is negative, only because it is negative, I have to reverse the less than sign. That's how inequality is. For an inequality to remain true, when you multiply it or divide it with a negative number, you have to reverse the inequality sign. It's basically almost the same as you take this and bring it over this side and take that and bring it over that side. But let's just stick with this expression now. Multiply or divide with a negative number, the inequality sign remains true. So let's go now. So when I divide this side by the negative 2, the negative 2 is cancelled away and I'm left with x. This less than sign reverses and becomes a greater than sign. And then negative 4 divided by a negative 2, negative will cancel, and then the 4 divided by 2 is 2. So negative 4 divided by negative 2 is going to become a 2. And basically that is your solution right there. X is greater than 2. That's your solution. You have solved it. All right. I'm going to do the same thing on this one. I'm going to make the x subject on this one, but this time I'm going to group the x terms on the right side over here. So it means then that I'm going to leave this 3x over here and take this x over onto this side and I have to subtract it. This sign stays as it is. Now this 3 is already there. I'm going to put it back as negative 3 on the left side. And then this negative 7, when it comes over here, becomes a positive 7. It's a positive 7 over here now. Then the 7 minus 3 is a 4, less than. Then this is 3x minus 1x. 3x minus x is 2x. And now to leave this x as a subject, I now need to divide by a 2, a positive 2. So I'm going to divide with a positive 2, but I'm not going to reverse the sign because now I'll be dividing with a positive number. So divide by a positive 2. And that's it. I don't have to reverse the sign. So I don't have to say this now, but I'm not reversing the sign. Simply because I am dividing with a positive number. All right? So the sign stays less than. So when you divide, this 4 by 2 becomes 2. The sign stays less than. I divide 2x by 2, I get x. So this is now reading 2 is less than x, if you read it from left to right. But if you read it from right to left, it is saying x is greater than 2. And so this whole inequality can be turned around and be written x. I can write that is, i.e., it is the same as, i.e., x is greater than 2 if you read it from right to left. And so you see the two answers are the same. That solution and that solution is the same. All right, everybody good with that? But okay?
Yes, sir.
All right. Now, the next part of the question told us to do a couple of things with the solution. It says we are to draw a number line represent this solution. And we are also to write down the solution set. All right, so let's do the number line first. So the number line is that you want to represent this inequality on a number line. So the critical value is 2. All right, so you have to show 2 on the number line. So I'm gonna draw the number line. Let's put 0, 1, 2, 3, 4, 5. That is enough. I just want to make sure that there's 2 on there. -1, -2. So this inequality really starts at 2. The critical value is 2. So I put a circle on the 2. But this circle that I'm putting on the 2, I have deliberately left it unshaded because there's no equal on the inequality. The unshaded circle on the 2 really means that 2 is not a valid value. It's just that the inequality is starting from 2. But 2 is not a value. No? So for example, 2.00001 would be good. So this is just to basically say that is the limit of the inequality. That's where the inequality starts. That's a critical value. That's a reference value for the inequality. And then the values of 2, the values that are greater than 2 are to the right over here. So to show that you really want this side of 2, you put an arrow pointing to the right. That is your inequality number line on a number line. And here you could also write x is greater than 2 on this. Now, the difference I want to point out now is that if the inequality instead, let me use a different color. If the inequality was instead x greater than or equal to 2, if it was that, then this would include 2. It means that 2 will be included. And to show that 2 is included in the solution, you would have to shade the circle on the 2. So by simply shading the circle on the 2, you will be basically indicating that 2 is included. So when the equal is included on the inequality, you shade the circle at your place on that critical value. All right? And the inequality instead would have been that. That would be the number line. If you had this as the inequality, I could put the inequality equal on this as well. That is what it would be if the equal was here. All right? Let's reverse it now because there's no equal there. And so let's go back to what it is supposed to be. Right? Greater than alone, the 2 is not included. 2 is not included, so you put an unshaded circle on the 2. All right? So that is a number line. All right. Then they want the solution set. So the solution set is very simple, you know. You're basically putting the solution in set brackets. So let's write the solution set. It's not complicated. So sometimes the question might ask you to write the solution set for an inequality. You're going to take this inequality and drop it inside set brackets. So it's going to just be this. You put the set brackets and write x is such that, and you basically just write about this thing. Right? X is greater than 2. Close the set brackets, and that's your solution set. And basically, like you put your solution in set brackets. All right, so that finishes part 2. All right, then we come to the last part down here. It says if x is an integer, let's look at it. If x is an integer, meaning you want whole numbers. Now, initially, if x is greater than 2, it means that you can have fraction values as well, you know. So it's not just 3 and 4 and 5 you'd have, you know, if x is just greater than 2, you know, right? It would take all the values up here, including the fraction value, like for example, 2.3, 2.9, 3.1, 3.7, all those fraction values, those decimal values will be valid on this inequality if they did not define x for us and tell us any limit on x or any condition on x. Here now we are given a condition on x, that x is an integer. An integer is a positive or negative whole number. So it means that we only now want the whole numbers that are greater than 2. We can't even include the 2, you know. The whole numbers that are greater than 2 continuing out to the right. Because the number line continues out there, you know, just that we don't need up space to show everything. So basically, your values, if you were to write your integer values of x, they'll be like this. Right? integer x values. If x is an integer, then these will be the values. X would have been equal to, or to be the values. First integer value would have to be 3. Remember, you cannot include the 2. Because the inequality is that x is greater than 2. So your values will be 3, 4, 5, 6. And then three little dots here means that you continue on and on and on forever. So those will be the values of x. 3, 4, 5, 6, 7, 8, 9, 10, and on and on and on. We don't have to show all of them. We show 4 here, and then I just put 3 little dots. These 3 dots usually means that you continue. All right? And those are your values. And the question is asking was for the smallest one. Smallest one is this first one right here. The 3. That's the smallest integer x. Smallest integer. If x is an integer, that will be the smallest value. It's x equals 3. That finishes that question. So this question was well done in the class activity. All right. I'm taking it that you did your own work, guys. Remember, you have to do your own work. You're not gonna learn anything if you don't do your own work. All right. And if you even have somebody like showing you something and explaining something to you, your aim is to understand it, not just copy somebody's work. That don't make any sense for big 15, 16, 17-year-old children. Don't make any sense. All right. At this level, you're trying to prepare yourself for an exam that you're gonna have to do by yourself. All right. So that is it. But all right, but good. This first one was fairly well done in the class. So I think everybody is good. But good, just making sure.
Yes, sir.
All right. Then we'll come to this now, this inequality, linear programming style inequality question. All right. A linear programming question where you're given the conditions and usually relate to some business and some business venture where somebody is going into some form of business and they want to know what is the best combination of things that they're going to sell, usually buy and sell. What is the best combination of the things that they're going to sell in order to maximize their profit or minimize their cost? So in the beginning, they won't know how many of the items they're going to buy. They don't know. But what they know are the conditions under which they're going to buy them. And those conditions are limitations and constraints, like boundaries within which you have to operate. And what you do, you use inequalities to represent those limitations and constraints. Inequalities, greater than sign, less than sign, greater than or equal to sign, less than or equal to sign, based on the conditions that are explained or described, using inequality to represent those conditions. Then you take those inequalities and you put them on a graph paper. You represent them on a graph. When you put all inequalities simultaneously on a graph, you end up getting a region, a polygon. It is usually bounded by the lines that are associated with the inequalities. It represents what we call a common region, meaning in that region, which is in the form of a polygon, it means that you can operate at any point, any condition, any combination within that region or along the lines, the boundaries of that region, if the boundaries are solid line boundaries, if the lines are included in the conditions. But when you want to work out your maximum or minimum of anything, maximum or minimum profit and so on, you go to the vertices and use the values or the coordinates at the vertices, because the vertices are the points where you have your extreme values of the x and y. Usually it's x and y. So you have your largest values of x and your largest values of y, meaning that the largest number of items and the smallest number of items at these vertices. So those are the points you go to work out the maximum something or your minimum something. And in a nutshell, that's how these questions are always set up. All right. So you don't know at the beginning how much you're gonna buy. So in this question, for example, it says a shopkeeper stocks X radios and Y, X phones and Y radios. So it's like they're going into business and they're going to buy some phones and radios to sell. But they don't know exactly how many they're going to buy yet, you know. So because they don't know how many they're going to buy, they decide that they're going to call the number of phones X and call the number of radios Y. They represent them with X and Y. And then they're going to, based on the condition, they're going to set up some inequalities with the X and Y representing in them. Now, the first condition they have here is that the shop has shelf space for up to 20 devices. The word devices here is taken to mean the phones plus the radios together. That's what it is taken to mean. There are X phones and there are Y radios. And what it is saying is that you basically can't put more than 20 devices on the shelf. So the maximum total number of devices you can place on the shelf is 20. Remember, you don't know how many you're going to have, You don't have to go to the maximum 20, the full 20. You can actually go less. So the total number of devices that you put on the shelf is going to be 20 or less. All right, so let's set it up. So we have X phones, where X is the number of phones. Remember, X is the number of phones. And we have Y radios. Y is the number of radios. You don't know X and you don't know Y. You don't know them yet. You don't know exactly how many you're going to buy. All right? This first condition is talking about the total, straightforward as I just explained. So the number of phones plus the number of radios can't pass 20 together. When you add them up, it can't pass 20. So it will have to be less than or equal to 20. That's what that first statement here means. They only have shelf space for 20 devices. So the total of the phones and the radios can't pass 20. 20 or less. All right? Then here now, they start to talk about money. And these questions will always bring some money thing into the play, for the most part. It says the owner of the shop spends $150 for each phone. Let's put it up here like a cost profile. All right? So this is the cost we're going to talk about now, the cost. He's paying $150 for each. $150 for each phone, meaning for one phone. And he's paying $200 for each radio. $200 each for the radio, for the radios. So if he buys two phones, it's 2 times 150, or 150 times 2. If he buys 3 phones, then it's 150 times 3. He's spending for the phone. If he buys 5 phones, it's 150 times 5. He's spending for the phones. Here he's buying X phones. So the money he's spending for the phones, let's write it down here now. Part 2. The money he's spending for the phones is 150X. I'm leaving off the dollar sign for now. This is just for the phones, money that he's spending for the phones. Plus he has to spend money for the radios. But he's spending $300 each for the radios. So if he buys 2 radios, that's 300 times 2. If he buys 3 radios, that's 300 times 3. If he buys 5 radios, that's 300 times 5. Here he's buying Y radios. You just have to don't know what Y is. So the money that he's spending on the radios is 300 Y. I don't need to put the dollar sign. So this is the total amount of money that he's spending on the devices. This is for the radios. So the total amount of money he's spending is 150 plus 300 Y. That's the amount of money that he's spending. All right? And they're going to give you some limitation now on how much this total spend can be. How they phrase it. They said she has $4,500 to spend on the purchase of the devices. See, devices again means the radios and the phones. That's what devices here mean. All right. So the total money that she's spending will have to be $4,500 or less, because that's the amount that she has. cannot spend more than you have. So the total spend can be a maximum of 4,500, but it could also be that you're spending less. So this total amount that is being spent can be less than or equal to the total money that she has, 4,500. And you must always simplify. So that's inequality for the second condition right here. No? But this can be simplified by dividing 2 by 150. All of these values are multiples of 150. So I'll divide 2 by 150 to simplify that inequality. You won't leave it like this. Always simplify when you can. So divide by 150. And so we divide this by 150, it becomes x. We divide this by 150, it becomes 2y. We divide this by 150, it becomes 30. I divide it by 150, get 3. And then the 0, get 30. So this now is really your second inequality. So we have two inequalities so far. Let me put them in boxes. I'll put this in a purple box. This is one inequality so far. And this is the second one. So it means that already we're going to have two lines on our diagram. So we're going to have to, in this question, we're going to draw a graph. All right? So that's the second inequality. Then down here now, there's another condition. And they require two more inequalities from this. It says, the owner of a shop stocks at least 5 phones and at least 5 radios. We have to know that the term at least means that amount or more. So at least 10, if you must have at least $10 to do something, it means that you must have $10 or more. A lot of persons, they see the term least and it causes them to put the less than sign. Just put the less than sign because they see the word least. No. Read the truth of the statement, of the sentence, the meaning of the sentence. At least 5 something means at least 5 means 5 or more. At least 5 means 5 or more. So it means that the number of right inequalities here. Let's put them down here. Let me put them on the screen over here. So it means that the number of phones, which is X, that means the number of phones is X, must be at least 5. The number of phones must be greater than or equal to 5. That's how you write at least 5. 5 or more. It means that you can have 6, you can have 7, and so on. Similarly, the number of radios, which is Y. Y is the number of radios. The number of radios must be 5 or more. Must be greater than or equal to 5. So these are your 2 additional inequalities. Let's put them each in a box. So this is a third one, and this is a fourth one. So you have 4 inequalities, means that you're going to have 4 lines. And generally speaking, since you have 4 lines resulting from 4 inequalities, your common region is going to be bounded by those 4 lines. It's going to be a quadrilateral. All right, which is what they want us to do next in this question. All right, here, draw the graph. All right, so those are the 4 inequalities. They now want us to draw the graph of those 4 inequalities. All right, so here, using a scale of 2 centimeters represent 5 divides on each axis. But I already drew this, give you a scale already, right here. So you need to worry about that. See, 2 centimeters to 5 on each axis. I did that for you already in a class activity. What they want us to draw the lines associated with the inequality. They want us to shade the region that satisfies all the inequalities. And then they want us to state the vertices of the shaded region. And the vertices are always very important, as I said. All right, let's do that part next. I'm going to do it right on this graph here that I have on the screen. All right, let's do it right here. So let's talk about this one first and how we represent that one. Now, inequality on a graph is really about identifying a region that is either above or below a line. The line is an equal mark. So if I, for example, have x plus y equals 20, this equal means it's just a line on a graph, just a line on a graph, the line itself. If I put the inequality sign on it now, like greater than, it means that if the line is like this, it means that I would want above the line because of the inequality. And in this case, because I have just greater than alone, I would have to draw the line broken anyway. So I would have to draw a broken line, x plus y equals 20. And I would have to shade above it. If this was a less than, I would shade below it. All right. So inequality on a graph is not just a line, it's being above the line or below the line. So we always want to decide first before we start if we want the region above the line or below the line. Then we're going to know if the line is drawn solid or broken. Because if the equal is included, it means that the line is a part of the inequality. And to show that the line is a part of the inequality, you draw the line solid, a solid line. If the equal is not there, for example, if I have a less than, as I just said, then you draw the line broken. A broken line means that points on the line are not valid. The line is not a part of the inequality. It is either you only want the region above a broken line or the region below a broken line. But when the line is solid, it means that points on the line are also valid. All right, so let's read into this inequality now. Now, a definition, as I said, for when the less than generally means below. When the less than means below, I have to remember this now, when the y value on the left side of this inequality is positive, which it is right here. So because the y value on the left side of this inequality is positive, this less than sign now means you want below the line. So for this line, let's put it in bracket here. I want below this line. The next thing is whether the line is solid or broken. The line is going to be a solid line because the equal is a part of the inequality. It means that I'm going to draw a solid line showing that the line is a part of the inequality. So you draw the line solid. And then the question is, which line? Which line is associated with this inequality? The line that just changes this inequality into an equal is the line associated with it. So the line we're talking about here is the line x plus y equals 20. All right, this thing look a little bit. Let me just make this a little smaller because the entire page. Let me make it a little smaller and zoom in. All right, yeah. Good. So it means that the line that I want is the line associated with this inequality, which is the line x plus y equals 20. Notice what I call an x plus y line. Let me show you quickly. X plus y line. So you see x plus y lines, they always go like so. Slant it down. And it's always such that the x value and the y value. We will go across the y-axis and the x value, and the x-axis is the same. So if this was n, some value n on the y-axis, and this is some value n on the x-axis, then this line would be x plus y equals n. So whatever n is the value that crosses the y-axis and crosses the x-axis. All right? So this is a common line to know. Since this x plus y equals 20, it means that it crosses the y-axis at 20 and crosses the x-axis at 20 and is like that. Right? So the common line to draw, guys. Common line. The more things you know, the better. So this line is going to pass through 0, 20 and going to pass through 20, 0. This is on the y-axis. This is on the x-axis. All right? Then we come to this line next, this one. Let's analyze it again. Remember, you either want above or below the line. That's your first consideration. Again, the y over here is positive. The y on the left side of this inequality here is positive. And when you have that, it means that this less than means below. If it was a greater than, it would mean above. But because it's the less than, after the y is positive on the left side, the less than means below. So we're going below this line. Again, the equal is a part of this inequality. So it means that the line is a part of the inequality. A line is a part of the required region. And so we're going to draw a solid line to show that, a solid line. And the line that you're drawing is one associated with this inequality, which means it just replaces inequality sign with an equal and write back everything the same. So the line we're talking about is x plus 2y equals 30. See, all the difference between this line and this inequality is that this inequality becomes equal to know what the line is. Right? So this is the line associated with this inequality. All right, so I want to draw this on a graph. A quick way to draw a line like this on a graph, which you're gonna see frequently in these topics, linear programming, is to just basically put on 2 points. The first point, to give it an x value of 0. The second point, to give it a y value of 0. You're going to use the equation to work out the value coming here and the value coming here. All right? All right, let's do it now. So at this point, where the x value is 0, it is as if this gone and you're left with only 2y equals 30. Because x is 0 now, so you're left with 2y equals 30. And if 2y is equal to 30, divided by the 2, you see that the y value is 15. You can see then that when the x is 0, the y is 15. That is it. So this is 1 point. The second point now is where the y value is 0. So you're going to put the y value of 0 right here. And so that this gone. And if this gone, now you see that the x equals 30 when the y value is 0. And so that is it. X is 30 when the y is 0. So that's a nice quick way to do a line like this. So this one is on the y-axis. You see, it has a y value only. So this is x value is 0, the y value is 15. So this is on the y-axis. So some people mix them up. That's a y value. It must be on the y-axis. And then this now is the x value. So it's on the x-axis, but the y value is 0 there. So this is on the x-axis. So basically, I've plotted the points where this line crosses the y-axis and the x-axis. It's a nice quick way to draw a line like this on a graph. And then now we come to the next 2 lines, which are these. These are like easy ones to do, right? So this one first, again, it's going to be above because of the greater than sign. So x greater than 5. So we're going to go above. And then it's a solid line because the equal is a part of inequality. So it's going to draw a solid line. And the line associated with x greater than or equal to 5 is just x equals 5. And then x equals 5 is a vertical line passing through 5. Okay, now look here. Remember that the y-axis is the line x equals 0. So x equals 5 is going to be vertical like the y-axis and pass through 5. Simple as that. Just remember that the y-axis is x equals 0. Then we need to do this one now. So this, I've drawn this to show that I'm going to be drawing a vertical line. This. So x equals 5 is a vertical line passing through 5. Then for this one down here now, let me shift it down a little bit. For this one down here is y over here, and then greater than means above, right? Because y over is positive, greater than means above. So this one now going above again. The line is drawn solid because the equal here is a part of the inequality. So you draw a solid unbroken line, a solid line, or an unbroken line. And the line drawn is one associated with this inequality, which is now y equals 5. Now y equals 5 is an horizontal line passing through 5. If you don't remember, you can remember it this way. Because the x-axis is a line y equals 0. That's the equation of the x-axis, y equals 0. So y equals 5 is going to be horizontal at the x-axis and pass through 5 right here. So that's y equals 5. All right? So we now have all the information we need to draw this graph. All right, so let's draw it over here now. The first one is x plus y equals 20. This one. I'm going to draw it in blue on the graph. X plus y equals 20. Now, I'm not able to draw a straight line, guys, so you have to bear with me, right? But it crosses the y-axis at 20 up here and crosses the x-axis at 20 down here. And you need that straight line, x plus y equals 20. X plus y equals 20. therefore going to also pass through 10, 10, as 10 and 10 is 20. So it must pass through 10, 10 right here. It must pass through 5, 15, as 5 and 15 is 20. So it must pass through this point. It must pass through 15, 5, because 15 and 5 is 20. So you see, pass through all those points. But you all you really needed were these two and draw, right? But because I'm on this device, I want to put in these other ones and draw the line. So the line is this. That's the line x plus y equals 20. You must always label the line with the equal sign because the line represents the equal mark. So this line is x plus y equals 20. Do not put an inequality on the line. Because you want below the line, what I'm going to do is put the arrow pointing downwards. It means that the region that I want is below this line. But we're not going to shade yet. All right, we're not going to shade it. The region that we want is below that line. All right, let me take out some of these marks where we have the line. All right, so that is the line. So that we use these 2 points alone. Y-axis intercept and x-axis intercept to draw it. So the next line is this one now. This one. And the next inequality represented that one. This is what we're talking about right here. That line. We said the pass through 0, 15 on the y-axis, which is right here. And it pass through 30, 0 on the x-axis. So out here, 30, 0. That is it. And we just need to draw a straight line through those 2 points, so through this and this. Straight line. So let's line it up and go like so. That is it. I can't draw it straight with this device, guys. So you have to bear with me, right? I'm not able to draw it straight with this device. And extend it out and then label the line with the equal sign. Let me take this out, take off this y equals 0. So the line is x plus 2y, x plus 2y equals 30. And I want below this one as well. Remember? Below. I'm going to put an arrow pointing down on this one as well. So it means that the region that I want right now is below this line and below this line, below both of them. Below both of them. So it means that we want somewhere under here. But we have to put in the other two inequalities first. We're not finished that yet. All right? So we have to put in this one now, which is above the solid line x equals 5. So as we say, x equals 5 is a vertical line passing through 5. So 5 here, I'm going to draw a vertical line through it. So that vertical line, passing through 5, use your ruler and you draw it like this. Label the line with the equal sign. X equals 5. You want values that are greater than 5, so you want values on to the right of that. Put the arrow pointing to the right. So it means that my region now is somewhere down here so far. We're not finished yet. We have one more line to put in, which is the y equals 5 line for this inequality right here, this one. That now is a horizontal line through 5. So 5 here, we want a horizontal line through it. So you draw a horizontal line passing through 5. And then you label the line with the equal sign. The line is y equals 5. Do not put any inequality on the line. And for this one, we want up, want above this line. Above that line. So the region that satisfies these inequalities, let me use a different color for it. It's right inside here. Above this line, above this horizontal line, below this one, and below this one. So the region that I want is inside here. I'm shading now. That is the region that satisfies all inequalities. Don't shade in here, so which is wrong. Don't shade in here, so that is wrong. Can't shade anywhere over here, so wrong. That green section is the only section that is valid. And then now the lines bounding the region are also valid. These lines bounding the region are also valid. So I can draw it out in green for you. So the region and the lines bounding the region. So you cannot operate outside this region. You cannot operate the business of the phones and radios outside this region. Let me answer this part. Give me a surprise. Hello? Yeah, I'm in a class, you know, what's up? You get them? It's 2 times ago? You lie. Okay. All right, cool. I'm in a class now, we talk. Yeah, cool. All right, guys, sorry about that. All right, so that is a region that you can operate in. So you can't put any point outside of that green region. All right, you can operate along the sides because all the sides are solid. And you can operate anywhere inside this region, anywhere inside this region. So for example, let's say this is 8 phones, and say this is 9 radios right here. That's 8, 9. So you can stock 8 phones and 9 radios if you want. It's okay because it's within the region. It's okay to stock on the shelf 8 phones and 9 radios because that is within the region. So that will be a valid point. Right? So in the class, I saw some persons using this point up here, right here. So it was 515. You cannot use that point. That point is not inside the region that satisfies the inequality. All right? The furthest you can go, right, is at the vertices. Here is the highest you can go on this line. Right? This vertex, the furthest you can go this way on this line, that vertex. Right? And then this also is a vertex as well because 2 lines meet there, 2 different lines. So this is a vertex as well of the region, and this is another vertex. So it has 4 vertices. Let's name them A, B, C, and D. A question did ask for them, right? See there? Ask for them and it says state the coordinates of the vertices. So we just have to state them. All right, so let's do that down here. So now. So in the second part, the third part of B part 3 was to name the vertices and state the coordinates. So A is clear the point 5, 5, but you can see 5, 5. So A is a point 5, 5. Then B is a point 5, not 15. It's below 15. See? The 15 up here is 10 here. So this is halfway between the 10 and the 15. So it is 12.5. You can average them like a midpoint, 15 plus 10 over 2 becomes 25 over 2, which is 12.5. You can average them like a midpoint. Right? But you should know that halfway between 10 and 15 is 12.5. So the Y value here is 12.5 and the X value is 5. So B is a point 5, 12.5. Remember, you have to put the X value first in the bracket. Okay? Then C right here, C is 10, 10 clearly. See? 10, 10. So C is a point 10, 10. So C is 10, 10. And then D right here is a point 15 is the X value, 5 is the Y value, 15, 5. So those are the 4 vertices, 15 and 5. All right, that ends that part. Then we'll come to part C now. The part C now says, right here. Part C now says, the owner of shop sells the devices, meaning the radio and the phones, to make a profit of $80 on each phone, $80 for one profit, and $100 on each radio, $100 profit on each radio. So if he sells 2 phones, it's $160 done. If he sells 3 phones, his profit is going to be 80 times 3. If he sells 4 phones, his profit on the phone is going to be 80 times 4. Then for the radios, it's $100 on each radio. So if he sells 2 radios, it's 100 times 2 profit. If he sells 3 radios, it's 100 times 3. What happened in this question is that you don't know how many phones and how many radios. So you need an expression to represent the profit in terms of X and Y. See here? So he's going to do X phones. So it's 80 times X is going to be the profit on the phones. He's going to do Y radios. So it's 100 times Y is the profit on the radios. Here, they're asking us for the total profit, meaning the profit on the phones plus the profit on the radios. So for part C, they're asking us for the total profit. So when I say total profit, I'm going to put P dollars. So that means we don't have to put the dollar sign on what we're writing. I'll call it P dollars. Where the P is 80 times X. There are X phones at $80 each. So it's 80 times X is the profit on the phones. Plus the profit on the radios is 100 times Y. Because there are Y radios at $100 each. So it's 100 times Y. So this represents a formula of a profit. And some persons were trying to simplify. You can't simplify one side of an equation. In other words, you can't divide on one side of an equation. You cannot do that. Right? This is an equation. If you divide it 2 by 20, if you divide this side by 20 as well, so it don't make no sense. So you leave this as it is. That is just a formula for calculating the profit. That's a profit formula for part 1. So this is the answer for part 1. The next part now says we have to calculate the maximum profit. So the point to remember now is that the maximum profit will be obtained at one of these vertices. Always at a vertex. And majority of the time, you cannot look and know which vertex it is. You can eliminate a vertex. So you can eliminate this one, for example. You're definitely not going to maximize profit there. Because this one has more radios than this, but they have the same number of phones. And this one has more phones than this, but they have the same number of radios, which is 5. So you already know that A out of it, it don't make no sense to test A, analyze A. So your profit, maximum profit is going to be at one of these 3 points. And some persons were basically just doing these 2 and ignore that one, that's a vertex as well. You have to include it in the analysis. Why? Why do I have to include it in the analysis? Because if you're comparing these 2 to begin with, this one has a higher X value and this one has a higher Y value than the other. So you have to analyze both of them. You can't look and know which one is going to give you maximum profit. Better to test it. And then now, if you analyze the C and the D, this D has a higher X value, but this C has a higher Y value. And so you have to analyze both of them. You can't look and know which one it is. So for a proper analysis, you work out what the profit would be at each of those 3 points. It don't make no sense to do A. A clearly not going to give you the maximum profit. We have to test 3 points. All right. So remember now, and theoretically, you really can't have 12.5 radios in a guys. So remember, I told you in the class that if you cannot use a vertex that will go along the side, you really can't use 12.5 radios enough. You can't sell 12.5 radios enough. So really it should be either 512 or 513. But it can't be 513. Why can't be 513? Because 513 will be taking you outside the region. This is 12.5, you know. 12.5 is the Y value. 13 will take you up here outside the region. 13. 12 is taking you back this way. So if you do 512, you're going to be on this line. So really and truly, this analysis should be on 512. But I allowed 513 in the class to say if 512.5 was the point that you get, you couldn't use 512.5 and you'd have to go now and say 512, not 513. But I allowed it to use it in a class for the purpose of the analysis. But you know it's one of these 3 points, B, C, or D. All right, so let's go now. So we're gonna have to test for the maximum profit. So for part 2, we're gonna have to test for maximum profit first. Test for maximum profit. Test for maximum profit. We're gonna test point B first. B, which is 5, 12.5. You basically plugging in these values in this profit formula for the X and the Y. That's what they're doing. I'll work it out. All right, so the profit at B would be 80 times 5 plus 100 times 12.5. And you work that out. I'll make the circle smaller again. Shift it down and make the circle smaller. All right, you work that out. I think this was like 1650 or something like so. I don't 1625. Somebody can, what was this figure again? I don't want to have to work it out now. I kind of press for time. Gone after 12 already. But I go to that. What was this again? So what was this again? Somebody tell me, what was this figure again? Somebody who got it right. Hello? Hello? What is happening here? Students? Everybody sleeping?
No, sir. No, sir.
No,
No,
sir.
anybody? What would you describe in class? What was the answer for this again? What was the value I got for this? It's a question that we did in the class. I'm just going back over it. I don't remember. I have to work it out. All right, let me work it out. Oh, Lord. Can't believe this. 80 times 5 plus 100.
Sir, it was 1,625.
I put on my ask that, man. So I'm ask,
1,650, actually.
50, yeah. 1,650. That's what I wrote first. All right, and I want to do C, which was the point 10, 10. So probably, oh, no, interested in this because I don't understand it already. What's the other work? So let's try to do this over again for. This worked out to be 1,800. But not everybody was 100% comfortable with it. So that's why I have to go back over it and explain it again from scratch. But oftentimes, if you can understand one, you're good with the rest of them, So D was a point 15.5 right here. 15.5. Profit at D would have been 80 times the 15. 80 times the 15 plus 100 times the 5. 100 times the 5. I think this one was $1,700. And so the maximum profit is this figure. That's the maximum profit at this point. 10 and 10. So you're gonna write. Therefore, maximum profit is, and put the dollar sign, $1,800 when 10 and 10, 10 phones and 10 readers. 10 phones and 10 readers are sold. All right, sound like you guys not interested in this, but that is it. That's come to an end. But I have to go through the class activity, guys, because not everybody get it so good, clear. So I'm going to go through it and explain it, right? Go through it and explain it. So maybe some of you got everything right and you're good and it's boring for you to be going back over, but such is life. More math equals better math, I like to say. All right. And some of you even got it right. There's still one or two little blemishes that we need to clear up. Right? Because we're striving for perfection. All right, let me do a couple of questions that I sent you last night, all right? To do on the past papers. So I think one that I sent, you want to do on the linear ones first. Let me see which paper that was on. I want to do one of the linear ones, simple ones first. And I want to show you a special question as well. I'm looking in the blue. if I can find which paper it was on. So I don't even know which paper it was on. Let's see. What I sent last night. All right. I was good them in the order that I sent them. So June 2021. Sent one on this paper last night. I got number 80. It's 2180. All right, here it is. 8E. Let's run through this quickly. Let's just do them in the order that I sent them. It says, Marla buy 2 types of phones, mobile phones, B flow and C flex. We're just gonna call them B and C for simplicity, right? B and C. So B phones and C phones from a company retail. It says one B phone costs $60. Let's write it down here. So put information here. So you have B and you have C. In terms of cost, the B phone is $60 each, and the C phone is $80 each. All right. She buys X of the B phone, so she buying X of this one and Y of this one. So in terms of the number, it's X and Y. So I'm gonna shift this over a little bit. I'm gonna write XB phones and YC phones, and then this is the cost for it, right? XB phones, YC phones. She buys XB phones and YC phones. It says Marla must not spend more than this. So the total that she's spending can't pass this. So the total that she's spending is 60 times X, 60 times X, plus 80 times Y. 80 times Y. Can't pass this. Not spend, must not spend more than this. You can't spend up to this in or less. It has to be less than or equal to 1,200. That's the inequality. But you have to simplify it. This can be divided down by what? 20. Yeah, we can divide this through by 20. Right? Divide this through by 20. This becomes 3. This becomes 4Y. And this becomes what? 60. 60. But good with that? That is it. But okay with that?
Yes, sir.
Student, not interrupting no one. It says the number of B phones, remember the number of B phones is X, must be greater than or equal to the number of C phones, which is Y. Let's make sure again. The number of B phones, which is X. Right? So this is XB phones must be greater than or equal to the number of C phones, which is Y. It says write down an inequality represent information. That is it. X must be greater than or equal to Y. I don't like to read my inequality this way. I like the Y on the left side. So I prefer to turn it around and write it as Y less than or equal to X. Because if you go to draw this on a graph, you might think this greater than means above, but see, the Y is on the right side. So really and truly, it is this one. So this one is really a below. This is really a below. So this one is below. This one is really below. Solid line. Y equals X. So some person might go above because of the greater than sign, but I said Y must be positive on the left side. And so I will take this inequality and flip it around like that. And then now you see that really a less than you have, which means below. All right, so this greater than don't mean above, guys. but the y is on the right side. All right, pay attention to that. Ah, they wanted to draw the graph. Oh, I remember this question. I don't know if any of you noticed it, but the scaling kind of messed up. Let me show you what does that mean with this. I remember this question. So I didn't point out here. These are 4 centimeters and I give 5. Right? And then up here, scale change. Look, it's 4 centimeters, give you 5. But not up at the top here, it is 1, 2, 3, 4, 5 centimeters for the 5. So CSEC kind of mess up the scale. Remember, they're not perfect. Not everything that they do makes sense. So if I'm in the exam and I recognize this, that the scale is messed up, I'm going to change it. So I would change it on the exam paper if I were you. All right, I would go in the exam room and I would make a change to the scale. I would erase these and put my own scale on it. All right, because that scale is not a friendly scale right now to use, because it is inconsistent. All right, it is inconsistent, not correct. How many inequalities we have? But here now they want us to represent the 2 inequalities on the grid below. Label the region R satisfy the 2 inequalities. All right, so let's see who got it right. Let's see who got it right. So the first line was this one. We need 2 points on that line. To get 2 points on this line, this one means below. Let me write out the meaning for each of them. Right? I'm trying to move a little bit more quickly because I spent a good bit of time on that first one, explaining everything. And with this is now just more of the same. So whatever is positive, so this less than means below. The line equal is there, so you're going to draw a solid line. And the line you're drawing is 3x plus 4y equals 60. All right, so you need 2 points on, let me write it here. 3x plus 4y equals 60. You need 2 points on this line. So one is going to give an x value of 0 and the other is going to give a y value of 0. So when you plug the 0 here for the x, this will be gone. You're going to left with 4y equals 60. If 4y equals 60, then the y equals 15. So the y equals 15. So you pass through 0, 15. And then now here, when you get the y value of 0 here, it should be gone. You're going to have 3x equals 60. If 3x equals 60, then the x is 20. 20. I don't know if this is going to be able to fit on the graph, but I want to show these points can fit on the graph. All right, 20. I'm changing the scale, you know. And then this one I said is below y equals x. So let me put in a scale now. I want to make sure that it go to 20 and go up to 15. All right, so let's say if 20 is possible. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Nope, not enough. So I'm not using that scale. I'm going to use 2, 4, 6, 8, 10. Sorry, 2, 4. Go back. I'm going to use 2, 4. I'm going to put 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Because I see it mess up the scale. So I'm changing it. 2, 4, 6, 8, 10, 12, 14, that's 16, 14. This is 16. We're going up to 15. That's the scale I'm using, guys. That's the scale I'm using. So I'm operating right inside here. They mess up the scale, so I'm changing it. All right, I'm changing it on the exam paper because the scale was messed up. And I will do that in the exam room. I might put a note and say error on the scale, error on the scale, and they will see it. I might put this on my paper and say error on the scale, so I'm gonna change it. That's why I change it. All right. Then I'm gonna go now. I'm doing this one first. 0, 15, 20, 0. 0, 15, 20, 0 for the first one. 0, 15, 20, 0. Let's do that in blue. 0, 15. 15 is going to be right inside here, so halfway between the 14 and the 16. Then 20 is going to be right here. Use the ruler and draw a straight line down there. So use your ruler and you draw a straight line. So you go like that. Label the line with the equal sign. This is 3x plus 4y equals 20. That's what it equals 60. Yeah, 60, sorry, 60. All right. And then we want below that line, just below, just below both of them. Below both of them. So I want below this line, put our pointing down. The next line is y equals x, right? Y equals x we're drawing, and we're going below it as well. So below y equals x. Y equals x is a straight line down the middle. Pass through 0, 0, pass through 10, 10. Where's 10? 10 here, so 10, 10. All right, pass through 8, 8 right here. So you're drawing a line like this. Use your ruler and draw it. Pass through 6, 6 right here. Pass through 4, 4. Y equals x is that line. Use your ruler and draw. Y equals x. I'm going below this line as well. So below both lines. So the region that you want is below this one and below this one. And so your region that you want is down here. Below both lines, all the way down to the x-axis. Remember now, the number of phones will be greater than or equal to 0 naturally, right? So above this, y equals 0 means is y greater than or equal to 0. That's why I can go above this line. That's the boundary line as well. So that is my region. The number of phones must be greater than or equal to 0. So those are like understood inequalities. That's the region at all. Oh, that's a label it as R, right? So label it as R. Did they say that? Label it as R. And put a red R on it. Put a red R on it. R. They didn't say shade, they said leave it as R. That is it. That's the correct answer, guys. So those who did up here, learn from your mistakes. I think the key thing was to recognize that this inequality, the statement gave us this, but reading this, it has to be below. I have to turn it around and make the y come on the left side for the less than to mean below. It's greater than don't mean above, because the y is on the right side. But I go to that. But okay? Students?
Yes, sir.
All right. Down here now, it says the total number of mobile phones is x plus y, naturally, right? Total number of phones is x plus y. It says, according to the graph, what is the largest possible value of x plus y? Which vertex the sum of x plus y is going to be the largest? That's what they want. Which vertex the sum of x and y is going to be largest? That's what you want to find out. So looks like here to me, here says 0, 0. You have to go to the vertices, guys. These are the 3 vertices here, here, and there. Those 3 vertices. So right here, so x plus y is going to be 20. Right here says 0. So that's out of it. Right here, this don't reach 10 and 10, because it's 10, 10 right here, so this is 10, 10. So this point, the x and the y value less than 10. See? The x at this point, this vertex, the x value is less than 10 and the y value is less than 10. So there's no way the sum of this point can be 20, even though you don't know the actual coordinates there. You don't know the actual coordinates there. Well, you know, say less than here, so. But if you estimate it, this point, the x and y value is same, because it's on this line where y equals x. So that point maybe looks like about 8.2, 8.2, 8.2, 8.2. So let's see, if you add them, it's less than 20. So this is it. 20, 0. That's the answer. 20, 0 out at that point. All right, so it says, what is the largest possible value? 20. X plus y equals 20. Out here, so the largest possible value of x plus y. What do you go to that? But okay?
Yes, sir.
Yes, sir.
So 20. That finishes that question. All right. Remember, guys, if I got it wrong, redo it. More maths equals better maths. If you got it wrong, redo it. All right. So the next one I want us to do is on 2023. It's the next one I gave you, 2023. All right. Let me get it like this. Let me get it like this. 2023. June 2023. When I come upon the linear one, I show you something, right? I want to show you guys a special question that you should know. This was question 2B. What if it is this one? All right, so this one is a straightforward one. Solve the inequality. So you basically want to group the x terms on the same side, or this is m. All right, so it's simple. You're going to take this and bring it over here. You're going to get 8m minus 4m less than or equal to, this is 5 right now. Then this 12 goes over here becomes a negative 12. The normal transposition. So this negative 8m comes over here, becomes a positive 8m. This minus 4m stays minus 4m. This 5 on the right side stays 5. This 12 comes over, becomes a negative 12. This side, therefore, is 4m. Less than or equal to this, 12, negative 7. We divide by this 4. It's a positive number, so there's no need to reverse the sign. You divide them by a positive number, so the sign stays the same. So you're going to get m less than or equal to negative 7 over 4. That is it. You want us to do anything with it? I'll just solve it. That was it. Nothing else. Just that. Just that. All right, let's continue. Let's continue. What was the next question? What was the next one I gave you? I also gave you 2022 question 2C. January 2022 question 2C. 2022 question 2C. Right here. You must see that these things easy now, guys. If you can do them in the class, you can do them in the exam room. Question 2C. Right. There you go. So this one, they wanted to solve it, right? It says, look what this one says, you're gonna solve it, but believe what it says. It says determine all integer values of x that satisfy this inequality. Determine all the integer values. So the first thing you want to do is make x a subject in the middle there. All right? So you want to transpose everything away from that x and leave x alone in the middle. First thing we're going to do is move this 3 by multiplying both sides by 3. Multiply both sides by 3. That will eliminate 3 from the middle. When you multiply this by 3, it becomes negative 3. The sign stays less than. The 3 is cancelled away. You get 2 minus 4x. Then less than, and then this multiplied by 3 gives me 15. Then I need to get rid of this 2. How do I get rid of that 2? I subtract 2 from all sides. Subtract 2. Again, I don't reverse any sign because I'm just subtracting this 2 to get it from the middle. So when I subtract the 2, when I subtract 2 from this, it becomes negative 5. Less than. This in here becomes a 4x. A minus 4x, sorry. Less than. Subtract 2 from this, I get 15. I get 13, sorry, 13. 13. Then I need to get rid of this negative 4. I have to divide by the negative 4. But because I'm dividing with a negative number now, I have to reverse the inequality sign. So I'm going to divide by a negative 4 and reverse. that less than signs, two less than signs, that we reverse both of them. So I'm gonna get this side divided by -4, it becomes a positive 5/4. This side is reversed to greater than. The middle now is just x. This is also reversed to greater than. This becomes -13/4. 13/-4 is the same as -13/4. All right, so it becomes a -13/4. -13/4. All right. Now, as I said to you in the class, you should always turn your inequality, your interval like this, so the smaller values on the left, the larger values on the right. Because you want your values, you want the inequality to be in the same alignment as a number line. So I'm going to turn it around, turn it all the way around. So I'm going to write it as IE. Put this on the left side, which is -13/4. If you read it from the middle, you say -13/4 is less than x now. Read it this way. -13/4 is less than x, is less than x. All right, that's what that side is saying. And then here now is saying that the x is less than 5/4. The x is less than 5/4. This x in the middle is now less than 5/4. So generally speaking, if I turn this inequality around, these two signs reverse as well. That's what happens. All right, those two signs reverse as well. So this is it now. And the question wants us to write down the integers only. So a way to do that is to maybe show this on a number line. Just additional work, I'm going to show this on a number line. But what is this value really? This value really is -3¼ less than x, less than. This value is really 1¼ So if I were to show this on a number line, -1, 2, -1, -2, -3, -4. All right. So this end, -3¼ It's a -3 here, it's a -4 here. It should be -5. This is -3.5, sorry. It should be -3¼ right here. So like I divide this into 4 equal parts. Right here is -3¼ right here. So put an open circle on it. That's why it starts. And then here now is 1¼ So between 1 and 2, this is 1.5. Split that into quarter. Right here is 1¼ right here. The other circle is on it for this end. And your values is between it. Your x values are between there. Right? X values are between there. That's a number line for this inequality now. So where are integer values? The integer values here now. These are integer values that are valid within the region. Between these two red marks, what are your integer values? See them here? The whole number values. And so the answer would be x equals -3, -2, -1, 0, and 1. Those are your x values. All your integer values for this interval. But go to that. So I just did the number line for you to understand it. But everybody go to that?
Yes, sir.
This is one of those special questions, guys. I'll put this in the special questions book. This is one of those special questions where, you know, you had this situation right here and you have to turn it around. And they're asking you, not just for the solution, but they're asking you for the integer values. So you need to see the values. So a good way to do it is to put it on a number line. So the integer values that are in that interval jumps out at you. Clear. All right? Jumps out at you. Because right here, so as I said, is 1¼ and right here is -3¼ All right, and that is it. So your integer value is within those two red marks, right? Because your region is between these two red marks. And you want the whole number values between those two red marks, which you can see them on the number line. So this is a special question, guys. I'll put this on on a paper. But let me show you another question that I would say is a special question. I was giving an example and how you have to approach, right? I was making up one. Let me make up one now and show you. Let me zoom in right here and make up one and show you. Now watch this now. Suppose you get an inequality like this. Special question. Make a note of it and write it down. Now, I've never seen CSEC set one like it, you know. But that don't mean that I can't. All right? So if I give you one like this, I'm gonna make it kind of simple. If I give you one like 2x minus 3 less than, and I put our x value over here as well, like maybe 3x minus 5, and I put an x value on this side as well. I'm saying greater than, and I might say something like 7 minus x. I just make up one. I don't even know if it's possible actually. Don't put 5 inside here just for some. And I give you that. If you notice, you have x represented on all sides. So the method that we used up here a while ago, where we transpose everything away from the x in the middle and left and just work with the one inequality, the one expression. You really can't do that with this one, guys. Right? Because you have to be doing the same thing to all three sides. You're not able to do the same thing to all three sides and end up with just an x in the middle. Right? Because on this side you have a minus x, and on this side you have a 3x. Right? So if you do the same thing with anything you do on this side, it's going to affect this side differently, and vice versa. All right. So when you have a situation like this, what you have to do is break this out into two separate inequalities. This part of it, let me break it up. Let me show you. Put a box around it. So you have to work out this half of it and work out this half of it separately. You have to separate them. All right? Separate them. If you notice, the two of them includes the middle. All right? So if I take the left side first and put it in red, just to highlight it, I would be solving 7 minus x less than 5x minus 3. And then I'll be doing that and what the part in purple would be 5x minus 3 less than 3x minus 5. I have to do them separately. And it's like I'm solving this for x, make x a subject, and solving this to make x a subject separately. So I want to make x a subject of this one. I'm going to transpose this x over here and make it become 6x, right? Sign stays the same. Let's go back for the ready. So we'll get less than, take this minus x and carry it over here and become 6x. Take this minus 3, carry it over there and it becomes 10. And then divide by the 6, right? You get x greater than 10 over 6, which is 10 over 3. This is 5 over 3. That's what I have. That is what? 1 2/3. So you get x greater than 1 2/3, which can turn the other way around and write x greater than 1 2/3. That's on one side. Right? I'm going to show you put them together. And then I'm doing this, solving this one now that is in purple. You have to combine the answer now and see what the final answer is. So if I'm combining these two now, right? I'm going to transpose this 3x over here and subtract it. So I'm going to get 5x minus 3x when I bring this over. And then this side is less than still. This is negative 3 over here. Negative 5, sorry. And then this negative 3 goes over and becomes a positive 3. Now this side becomes 2x. Less than, this becomes negative 2. Nice. And then divide by the 2, I get the x is less than negative 1. So look what I'm having now. I'm having x is greater than 1 2/3 and x is less than negative 1. So what you want to do now is that number line combining both of them. number line combining both of them. Let's put it right here. So like I have 0, let's make it wide. 1, 2, -1, -2. Right? So if I put this solution over here, I'm going to have the inequality here, -1, and then the 0, the circle and -1 less than. So I'm going to the left. That is x less than -1. And then I have this now, x greater than 1 2/3. 1 2/3 and put down in red. So this now you want 2/3 here. So like you divide this into 3 equal parts. This second section you divide into 3 equal parts like so. So it should be 1/3 and that will be 2/3. Right? You divide it into 3 parts. 1, 2, 3. So this will be 2/3 right here. This will be 2/3. So put the circle on that one, and then you're greater than it, 1 2/3. So you go on to the right. So that is the solution, x greater than 1 2/3. That will be an answer, this and that. So it will be this or that, but it's 2 separate intervals. But understand that? So if you have x on this side and all sides, guys, as I have in this question, if you have x values on all sides, you have to separate it into 2 separate, from the middle to the left and from the middle to the right, and work them as 2 separate inequalities to work it out. Special question, guys. Make a note of it. Make a note of it. All right. So we did the red here, and we did the purple here. I work them out separately. And then we'll put back the 2 answers together on one number line. Make a note of it, guys. I don't see CSEC setting like this yet, but I know that it is possible. And that's what you have to do, break it up. But I go to that. This is an exam. But okay.
Yes, sir.
Let's see if they are what happened to you today. All right. The next one I wanted to do is okay, this 2007 paper. 2007. You guys given some questions before that as well. I'm gonna see if I can go back and find them. 2007 had a nice paper on it. Let's go back to 2007. 2007 should be somewhere in here. It's here. 2007, right? So this is it. All right. It says a company manufactures gold and silver stars to be used as party decorations. The stars are placed in pockets so that each pocket contains X gold stars and Y silver stars. All right. So see there, X gold stars and Y silver stars. That's important information. So number of gold stars is X, number of silver stars is Y. You don't know X and you don't know Y. Then they started for us. They give us this condition and the right inequality. So it says each pocket must have at least 20 gold stars. Means that the number of gold stars must be greater than or equal to 20. So this first inequality is correct right here for this statement. Second statement says each pocket must have at least 15 silver stars. 15 silver stars. At least 15. It means that the number of silver stars, they want us to fill these out, fill out these boxes, right? So the number of silver star, which is Y, must be at least 15, means 15 or more, greater than or equal to 15. That is the second inequality. Then here now it says the total number of stars is X plus Y. In the pockets must be not more than 60, must not be more than 60. Meaning it can be 60 or less, can't pass it. Not more, must not be more. So it means that X plus Y can't pass 60, can be 60 or less, less than or equal to 60. That's what that means. That's the third inequality. Then for this one now, it is something I do from time to time. They give you the inequality and ask you to write the statement for it. And oftentimes, all you need to do is just read it straight. This X represents a number of gold stars. This is why the number of silver stars, but it's 2y, so that is twice the number of silver stars, or 2 times the number of silver stars. And this is a less than. Just read it as it is from left to right. Remember that X represents the number of gold stars, Y represents the number of silver stars. So if I were writing this, I would say that it means the number of gold stars, remember it was X gold stars, must be less than twice the number of silver stars. That's it. The number of gold stars, which is this X right here, must be less than this is twice the number of silver stars, less than twice the number of silver stars, of silver stars. That is it. But go to that. But okay?
Yes, sir.
Yeah.
So those are 4 conditions, right? It says write down the inequality represent 2 and 3. We did that already. In the box. Say describing reverse condition X less than 2y. We did it right here. Now, if I'm going to do this on a graph, I don't want to read it like this, because I don't want, for the y over here is on the right side, that less than do means below anymore. But I would just turn it around and write it as 2y. 2y greater than x. This would now mean above. This now means above. Broken line, because the equal is not there. Broken line. And the line is 2y equals x, which is same as y equals half x. 2y equals x is same as y equals half x. Right? That's what you have to draw, which is y equals half x. So if you're going to draw this on a graph, it's above your one. Plenty of people want to say that I'm going to go below, you know. But remember, less than means below only when the y value on the left side and positive. Right now it's on the right side. So that does not satisfy the conditions for less than to mean below. All right. One day I'll go a little bit more deeper with respect to the values to explain why you want the y value to be positive on the left side for greater than to mean above and for less than to mean below. I'll show you a little bit, but I think just understand, just believe what I tell you now, just understand what I tell you now for the time. I feel like I might complicate it for you a little bit if I try to go any deeper. Just appreciate that. But for greater than to mean above, the y value on the left side must be positive. For less than to mean below, the y value on the left side to mean needs to be positive. Right? Because generally speaking, it can be understood, it can be taken. It's almost innate to believe that greater than means above and less than means below. All right. So well, remember, it means that only when the y value is positive on the left side. All right. So we'll finish those 2. Next part wants us to draw a graph. All right. So I have to bring up a graph paper and draw this graph, right? So I wonder if I can go back to the same graph that we had. How can I sketch it now? Can I sketch it right here? So let me split the screen and draw it on that thing. Just scale up some quick and draw it. Maybe they use the same classwork paper. Let me see. Same classwork paper. But the classwork I'm up to 60. Did it? Let me see. Let me see. It's 2 centimeters. I would have to double the scale, right? If I'm going to use this, I would have to double the scale now. I'm going to do that quick. I have to double the scale to use this paper. So I'll make this be 10. Then this will be 20. Then this will be 30. Then this will be 40. 50. And 60. And 70. This is what they say. See, 2 centimeters to 10 on each axis. So let's do that. This will be 10. I'm doubling the scale. 20. 30. 40. 50. 60. 70. I just want to use the same thing that we have here. So I've doubled the scale, guys, right? To match what they've said. All right, so let's do it now. So remember now, this one means above a solid line that are equal, and it's x equals 20. You don't have to write this, you know, just say that in your head. All right? You don't have to actually write this. So x equals 20 is a vertical line through 20, a vertical line through 20. X equals 20 is a vertical line through 20. All right, so 20 here, let's draw it in blue. A vertical line through 20. So I want to graph a vertical line on this, on here. That is it. This is the line. You're going to label the line with the equal sign. X equals 20. And take an arrow pointing to the right. The next one now is y greater than 15. So this one again is above solid line. Y equals 15. Y equals 15 is a horizontal line through 15. So coming for the horizontal line. So this is 10 and this is 20. So 15 must be halfway between them right here. So that's why we need a horizontal line through here. So draw a horizontal line out here now. Draw it to the ruler, guys. Don't do straight line. And then this will be y equals 15. Yeah, label the line with the equal sign. Y equals 15. You want above this line. So the region that you want right now is somewhere up here. So, all right, we're going to put in the other lines first. The other line is x plus y equals 60, an easy line. X plus y equals 60, crosses y axis at 60, and crosses the x axis at 60. So here it is. This is 60. And 60 down here as well. Right here, 60. So that's x plus y equals 60, right? So it must pass through 30, 30 as well, which is right here. This is 20, so it must pass through 20, 40, right here. And 40, 20, right here. I'm just putting these additional points to help me draw the line right? So that's it. But generally, you would only need these 2 points. But use the ruler and line it up and draw a straight line down here. That's x plus y equals 60. All right, x plus y equals 60. Label the line with the equal sign. X plus y equals 60. And I want below that line. Yeah, this one was below. This one was below. Because y is positive, less than means below. The line is solid. The line is x plus y equals 60, which is an easy line to draw. That's it. We're going below this line. So reach that want is somewhere in this triangle right here. We have to put in the other line. Let's take this off. Let's take these off for the time being. All right, so we have one more line to put in now, which is this one. So the thing is, don't try to draw it like that. Better to draw it like this and know that it's above, which is really the line y equals half x. So y equals half x is going to pass through the origin firstly, but the c value, there's no c value there. And it can basically plot another point, like maybe 30, 15, because if x equals 30, half of 30 is 15. So to pass through 30, 15, for example. So you just put another point, or you can do rise 1, run 2, right? Rise 1, run 2, and get other points from the origin. So I am saying it's going to pass through 30, 15, which is right here. Right here, it's going to pass through that point. Right? So, and pass through 40, 20 as well, right here. 40, 20. So that line will be like this. Let's draw it again. That is a line. Oh, I need to draw it broken. Oh gosh. Has to be drawn broken. Leave it like that and then draw a broken line on it. And then delete the original one. It has to be drawn broken. Has to be a broken line, guys. Let me delete this now. Here it is, a broken line. And this line is 2y equals x, right? This line is 2y equals x. I feel like you can put y equals half, it's the same line. Y equals half x. It's y equals half x. Y equals half x. It is broken. Meaning the points on it not valid. I want above it. With the arrow pointing up. So you want above this line. So the region that I want, I'm going to mark it out in green. The region I want, I'm going to mark it out in green. This is the region that I want inside here. But what happened now? This region that we want, this side of it is not valid. I cannot use any point there on that side because that's a broken line. So if I were to draw in red, the sides of this region that are in green, same green. The sides of this region that is valid. All right. Then I could draw, I can come from here along this side. It's okay. Down here. I can come along this side. Once on this side valid. So in terms of the vertices that are valid, in terms of the vertices that are valid vertices, this vertex is valid, and this vertex is valid. This vertex is not valid because it's on a broken line, so you can't use this one. And this vertex is not valid because it's on the broken line, so I cannot use those two. So I'm the only two vertices that I can use. So I can use those vertices and I can come along any one of these sides. I can come along any of those two sides. So in terms of the region, those are the only two of the four vertices that I can use. So I can use those vertices or I can use any one of these red sides. But I can't use those two vertices on the broken line. But I understand that, but I go to that. But okay?
Yes, sir.
All right. So this is another nice special question with all these because the broken line is in there. You're learning about the limitations of a broken line. Can't use this point and can't use that point because they are on the broken line. All right. Let's see what else they want us to do. All right. So this question says, now after we draw the graph, this is the graph that we have on the screen there. And it says, draw all the four inequalities on the graph, right? We have gone ahead and shaded the region, right? Maybe they didn't ask us to shade the region, but that is, it says 3 pockets, see, you know, 3 pockets were selected for inspection. It says their content are shown below. It says the points, plot the points A, B, and C on your graph. Hence determine which of the 3 pockets satisfy all conditions. All right, we're gonna plot these points now. Let me take off these red vertices and plot the points in red instead, right? Let me take these off and plot the points in red. All right. Let's put the 3 points in red. So the first point is 25, 20. So the x value is 25 and the y value is 20. 25, 20. That's point A. All right, let's find it now. 25, 20. All right. So 25 is right here. 20 is right here. So we're talking about this point. 25, 25, 20 is right where those two coordinates meet right here. That's the point A. A is a good point. It's in the region. So we can tick A. A satisfies the conditions. A is inside the region. Satisfies the condition A. All right. Then B no. B is 35, 15. Let's see where 35, 15 is. All right. So 35 is right here. That's 35. Right here is 35. And 15 is on this line. So talking about this point right here that I'm going to mark now is 35, 15. That's where B is. That is outside the region that we want. The green region is what we can use. So B is not a good pocket with an X on it. B is not a good pocket. It does not satisfy the conditions. It is outside the green region that satisfies the condition. The next point is C. The next pocket is pocket C. 30, 25. Let's see where 30, 25 is. So 30 here, so, and 25 is right here, so. So that point would be right here, 30, 25. All right, right here is 30, 25. That's point B. No, C, sorry, C, the third pocket, C. And so that is it. C is also a good pocket. It's inside the region. So we can tick off C. So it says, hence determine which of the 3 pockets satisfy our condition. Satisfy our conditions A and C. Satisfy our conditions. And that is it. Always stay, guys. Everybody good? Everybody okay?
Yes, sir.
All right. What time is it now? After 1. All right. I want to do a couple more questions. I know we're going past 1. Started a little bit late. I don't like when the class is more than 2 hours on a Saturday, but I want to do a couple more questions, right? Let me see which other one I gave you. Let me see which other one I gave you. I gave you a couple of very simple linear inequalities. I can maybe skip those because I've done a question. I've done questions like this. I can maybe skip those and go back to the first set. I think there's a particular question I want us to do. Let me switch paper it's on. The first set that I gave you in the week. I think I gave you those on Wednesday. Let me see. Which papers those were. So I did this one a while ago. Let's see, let's see. I don't know which paper this was on. 2022. We just did June 2022 a while ago. 22 question 8. Let me see. Ah, 2022 question 8. I think I'll finish off with this one. 2022 question 8. Nice question. 2022 question 8. 2022 question 8. Let's see. 2022, January, June. January, June 2022. June 2022. June 2022 question 8. I'll finish off with this one today, all right? 2022 question 8. I'm gonna finish off with this one today. All these questions, you guys will have to do them again, you know. Remember that, you know. All these questions, you guys will have to do them again. I think I will clean a copy of this somewhere, but I'll just work with this one. All right, so I gave you this question to do. So let's run through it. I gave you this question to do. Let's run through it. All right, more maths equals better maths every time. Let's go. Somebody pay attention now. Last one we're doing. Let's finish strong. Let's finish strong. All right, let's finish this one strong. Not a lot of people here to that. But anyway, it's what it is. It says a rental company has X cars and Y minivans. X is the number of cars, Y is the number of minivans. You don't know X and you don't know Y. The company has at least 8 vehicles altogether. The word vehicles is taken to mean the sum of the minivans and the cars. Right? So it means that X plus Y, which is the total, at least 8. At least means greater than or equal to 8. Must be greater than or equal to 8. That's one inequality from that. It says the number of minivans is Y. Number of minivan Y is less than or equal to the number of cars, which is X. That's another inequality. It said the total number of cars, which is X, right here, total number of cars, which is X, is no more than 9. No more than 9, means 9 or less, means X is less than or equal to 9. That's the 3 inequalities right there. It says write down 3 inequalities in terms of X and Y, other than X greater than or equal to 0, to represent the information. But I go to that, see them here now. I'll place them on the statements. Understand that, guys? This first one says the number of vehicles must have at least 8 vehicles, means that the total must be 8 or more, at least 8. Altogether must have at least 8 vehicles. That's the first one right here. Then it says right here, illustrate the number of minivans. Why is the number of minivans? Must be less than or equal to, see there, less than or equal to the number of cars. X is the number of cars. Then it says the number of cars, see there, which is Y, which is X, sorry, number of cars, which is X, must be no more than 9. Can't pass 9. It can be 9 or less. So these are your 3 inequalities. Let's write them down. X, write them here. X plus Y greater than or equal to 8. Y less than or equal to X. And X less than or equal to 9. But I go to that. Those are your 3 inequalities based on what they have said. But okay. I don't like this session today, you know.
Yes, sir.
I don't like this session at all. First thing, a lot of people absent. And secondly, those of you present now communicate. You can tell me if you want to discontinue this sort of thing, and I don't have to do it, you know. I don't have to do it. Let's continue. It says a car can carry 4 persons. So a car can carry 4 persons. So if you have 4 persons in a car, the total number of persons in a car is 4x. All right? A car can carry 4 persons. So number of persons in a car, 4 people. Number of persons in a car is 4x. Those X cars, right? Yes. And a minivan can carry 6 people. And there are Y minivans. So number of people in the minivans is 6 times Y. This represents the number of people going. 4 persons in each car, so total number of persons in the car is 4x. 6 persons in a van, or minivan, so the total number of persons in the minivan is 6y. So this represents the total number of persons together in the X cars and Y vans. It says there are at most 60 persons going on a tour. 60 is the most. Can't pass 60. So this total number of persons going on the tour can't pass 60. It's less than or equal to 60. That's inequality, you know. And here, what they have done is to show this. So I have to show this is what they have said. And to get this now, we divide by 2. So you know, divide by 2. So we have this based on what they have said. So let me shift it here. And I want to divide this by 2. And we get this other one. Divide this by 2. And we're gonna get this. Divide that by 2. We're gonna get 2x plus 3y less than or equal to 30. That is the second inequality. What inequality we have so far? 1, 2, 3, 4. It's the fourth inequality. This is the fourth one. So we have 4 inequalities, so it's 4 lines. But good at that? But good?
Yes, sir.
Yes, sir.
More 60 process going on at 2, right? 60 is the most. Then it says, on the grid below, plot the 4 lines associated with the inequalities, and then shade and label the region that satisfies all inequalities are. So this one I want you to shade and label. So we need the 4 inequalities. Let's go step by step, one by one. The first one is x plus y greater than or equal to 8. So that's why what this one means again. Y is positive greater than means above. So this time we're going above. The line is solid because of the equal. And the line is x plus y equals 8. And this one now, y is positive less than means below. The line is solid because of the equal and the inequality. And the line is y equals x. So these are 2 easy lines, right? This one will cross the x-axis and the y-axis at 8. This one passes to the point where x and y values are the same. All right. Then now you have x equals 9 for this one. So this one again is below. Below. Again, it's a solid line because of the equal. And the line is x equals 9. 3 easy line that. 3 easy line to draw. 3 simple easy line. Then we have this one now. So this one now, the y over here is positive. So this less than means below. The line drawn solid again because of the equal. It's going to draw a solid line. And the line we're talking about is 2x plus 3y equals 30. So we need 2 points on it. Let's do it over here. 2x plus 3y equals 30. So to get that line, I'm going to plot 2 points again, quick and fast. One of them we give an x value of 0, the other one we give a y value of 0. For the one we give the x value 0, right here, this is going to be gone. You're going to be left with 3y equals 30. If 3y equals 30, then y equals 10. So 0, 10. For the other one where the y value is 0, put this y value equals 0. This is going to be gone. 3 times 0 is 0. You're going to be left with 2x equals 30. If 2x equals 30, then x equals 15. So 15. So this one is on the y-axis. That's one is on the x-axis. So you pass through 0, 10, and 15, 0. All right, let's go now. I'll put them on the graph now. So the first one we said was x plus y equals 8. And we're going above it, above it. X plus y equals 8, we're going above it. So that one crosses the y-axis at 8 and crosses the x-axis at 8. See here? 8, 8. I'm going to pass through 4, 4, for example, right here. So I'm going to pass through 2, 6. I'm going to pass through 6, 2. Pass through points where x and y are the same. So you're passing through all those points. Let's draw it down here now. Let's draw that one down here. Can't draw a straight line with this device, guys. I need to get the app. Get myself an app. This is x plus y equals 8. I'm going above this line this time. So the region that I want is up here. We're going above it. Take that, please. Mute the mic, please. Somebody's mic is open. Mute the mic, please. We're going above that line. Oh yeah, boy. Somebody's mic. All right, close. All right, so that's the first line, right? The second line is mute your mic, please. Somebody's mic is open. All right, the mic is open. All right, next one is this one. Y equals x. I'm going below it. Y equals x. Easy line. Pass through 0, 0, 1, 1, 2, 2, and so on. I've drawn it accurately, guys. So pass through 0, 0, It's going to pass through 4, 4 right here. You know that, right? It's going to pass through 8, 8. 8, 8 up here, so as well. 8, 8 right here. That line y equals x. So we're going to draw that line now. Right on the middle of the graph like that. Y equals x. Label the line with the equal sign. Y equals x. And then we're going what? Above or below? What was it again? Below this one. Below this one. So put our pointing down. So the region that I want is somewhere over here. See? Above this one and below this one. So the region that I want right now is somewhere over here. All right, let's continue. Next one. X equals 9. We're going below x equals 9, right? We're going to put in the line x equals 9. Where is 9? So 9 here, so want a vertical line through 9. This is it. X equal line. Take off this out down here. It's kind of in the way. Extend this further down. I'll put that up here above this line. So I mean, x equals 9 now. So 9 you want a vertical line passing through 9. So this is the vertical line. This one. This vertical line passing through 9. This line. Let's go all the way up. Label the line with the equal sign. X equals 9. And I'm coming to the left of this line. So the region that we want is somewhere inside here, so. And notice it is above this horizontal piece here. So these are 2 vertices, you know. All right, let's continue. Let's continue. All right, next line we want was this last one, right? Which is to pass through these points, 0, 10, and 15, 0. 0, 10, and 15, 0. 0, 10 is right up here. 0, 10. And 15, 0 is all the way out here. 15, 0. These 2 points. So we need a line passing through those 2 points, right? I want to kind of see where it cross this line, across this line. I use a rule and draw it, you know, but I want it to be accurate, right? So let me see. Use a rule and that looks like it. Right? That looks like it. Looks like it passed through here and here. I'm going to test and see if those pass through those 2 points. Let's do again. It pass through. Let's see if it pass through here. Hold on a second. What am I doing? All right. I'm going to see if it passed through those 2 points. That looks like the line. So let me test this point here. So this point is 6, 6. And this point is 9, 4. Let me see if these 2 points are on this line, right? This one good enough, 6, 6 on that line. And this point is 9, 4. Let me see if it is on those 2, if this line is correct. Because I can't draw it with a ruler. I'm just trying to check if they are correct, if they are actually on this line, which was, what is it again? 2x plus 3y equals 30. This line, 2x plus 3y equals 30. I'm trying to see if these 2 points correct. 6, 6. 6, 6. Would 6, 6 work on this line? Plug 6, it will be 2 times 6 plus 3 times 6. So plug in the 6 here and plug in the 6. Just testing if they are correct points. This will be 12 plus 18. Good. 12 by 18 is 30. So, all right, so that one good. And the next point I'm going to try is this point to see if that point is correct. 9, 4. 9, 4. So I'm going to plug the 9, 4 in there. So it will be 2 times 9. 2 times 9 plus 3 times 4. Now 2 times 9 is 18 and 3 times 4 is 12 is equal to 32. Good. So those points are correct. So the line is good. The line is good. So that is the line right here. So those are my lines, guys. Okay, those are my lines. So what is my region? It's the most shady region. So it's basically below this line too, you know. goes below this line. So the region is inside here, below this, above this, and below this. So talking about inside here. This is the region right here. So above this line too, you know, this is a piece. So this piece is a part of the vertices to above the x-axis there. So that is the region that we want. And someone put an R on it, right? Let's put a big red R in it. Let's put a big red R in it. A big red R. R. Inside that green section is R. All right? That is it. What a good so far? That is the region satisfying all inequality. I like discuss them. So I'm going to finish with it today. What a good?
Yes, sir.
All right.
Yes, sir.
So what else I want us to do? So draw the graph. All right. I did that, right? I'll shade the region. I will put in the R. All right. What else I want us to do now? So you know, it says determine the two combinations of the minimum number of cars and minivans that can be used to carry exactly 60 people to the tour. Exactly 60 people. So if you're going to carry exactly 60 people, it means that the X plus Y, not it was the X plus Y, those are the cars. You want a formula for the number of people to be 60. Remember, this is the line that is counting the number of persons. This line is the line carrying the number of persons. And this was the line that had a maximum of 60. See there? Right? See, at most 60. So if you're carrying that actual number of 60 persons, it means that you're on the line for the equal when it is equal to 60. So this now, when it is equal to 60, brought down to this line that is now equal to 30. So if you want to carry exactly 60 persons, you have to be on this line, 4x plus 6y equals 60. Number of people in the cars versus the number of people in the van must be equal to 60 if you can exactly 60 people. This now would break down to 2x plus 3y equals 30, which is that line that I drew there. So to carry exactly 60 people, you have to be on this line. You have to be on that line to carry exactly 60 people. So you're coming on this line now. This is the line that you have to be on to carry exactly 60 people, this line. And so remember, to get the extreme values, you have to go down to the vertices. So you're coming on this line 1 for exactly 60 people. But then you have to go to the vertices of the common region. So that is where you're going to get exactly 60 people carried. So those are the two combinations. So you can carry a combination of vehicles here, which is what? 9 cars and 4 vans. Or you can go 6, 6. 6, 6 at those vertices. Exactly 60 people on this line. Exactly 60 persons are people on this line. That's the line they're gonna be on if you carry exactly 60 persons. And then now to get maximum or minimum anything, you have to come to these two vertices. So those represent the extreme at which you can carry number of persons. So the minimum number of vans will be 4, and the minimum number of cars will be 6. All right, that's what it is. What the minimum combinations is? The two combinations to carry the minimum number of cars and vans. Exactly 60 people. So it's at those 2 points, 6, 6 and 9, 4. So what are the two combinations? 6 cars and 6 vans. 6 cars and 6 vans. That's one combination. Or 9 cars and 4 vans is the other combination to carry exactly 60 people. But I go to that. So the 6, 6 is for this point, and the 9, 4 is for that point. And the graph is telling you that. Number of cars and vans that you can use to carry exactly 60 people. But I got that?
Yes, sir.
All right. Then it says no. The company charges $75 to rent a car and $90 to rent a van. All right. Show that the minimum cost for this tour, when I say this tour, the tour they're carrying 60 people. Because this question is talking about a particular tour. This part of the question is talking about a tour of carrying exactly 60 people. So you want to see which of these two combinations gonna minimize the cost. Which one gonna minimize the cost? So what is the formula for the fee for the rent? The formula for the rent, let's go back for the blue. The formula for the rent R dollars. Let's say the rent is R dollars. The R is gonna be equal to $75 for a car and there are X cars. So 75 times X is paying for the cars. Plus $90 for a van. There are Y vans. So it's 90 times Y is the amount we pay for a van. So any combination of X cars and Y vans, that's going to be the total rent. So let's put it, total rent to rent those. So let's write total rent, total. So you want to see which of these now, these two combinations. These are the two combinations that you can go on the tour with exactly 60 people, you know, this tour, this particular tour of 60 persons. So you're going to test which one of these 2 points going to give you the minimum. Which are these 2 points going to give you the minimum cost or the minimum rental cost for the tour. So let's do 6-6 first. So 6-6. Let's call this A and B. Let's label them A and B on the graph so we can reference them. Let's call this one A and call this one B on the graph. So we have a reference for them. So this one is A, this one is B. Two combination of carrying exactly 60 people. We want to maximize the number of vans and cars that they can use. All right, so A is 6-6, right? A is 6. You want to work out the rental at E. A is a 0.66. So the rental at A, you plug in the 6-6 in this formula. With the 75 times 6 plus 90 times 6. I'm going to work that out. And then if you're operating at B, which is 9.4, and the rental at B would be 75 times 9 plus 90 times 4. Let me get a calculator already, so now. And see which one of them come out less. And the less, the one that is less must be this. All right, let's say we're showing them also which combination you're gonna have the rental minimum. All right, so the first one right here is 75 times 6 plus 90 times 6. What's happening there? Let's go again. 75 times 6 plus 90 times 6. 999. This is a 9991. So you're spending $990 to carry 60 people if you rent 6 cars and 6 vans. Let's look at this one now and see what happens. So that one will be 75 times 9 plus 90 times 4, not 9 times 4, and 90 times 4. 90 times 4 plus 90 times 4. See, you're spending more money to carry out the same 60 people if you use 9 cars and 6 vans and 4 vans. This is 103035. So there you go. This one is a minimum. This one is a minimum. The minimum cost. Remember, I told you that linear programming is that they want to maximize profit or minimize cost. This is an example of when they wanted to calculate minimum cost. So not all questions is about maximum. You either want to maximize profit or minimize cost. So that proves that the minimum cost is $990. So we can write it. The minimum cost is $990 when 6 cars and 6 vans are used. All right? Let's write it in purple. The minimum cost is $990 to carry 60 persons on a tour. When you use 6 vans, 6 cars, and 6 vans are used. That is it. I'm not going to do any more. I'm going to finish with this question today. I want you to redo the question if you never get it right. Redo it. Put this one in a special book, special questions book. This question I can ask a little bit differently from the others. Most times the questions are about profit. And most times they don't specify any particular condition, but I spoke about this in the class. I spoke about questions like this, information like this in the class, where they are directing you to one of the lines. So this question was directing you to this line by telling you that you want to carry exactly 60 people. Because if you want to carry less than the 60, you would go below the line. They will go in less than 60 people if you go below the line. That's what it is, you know. If you want to carry exactly 60 people, you have to go on the line. You have to go a point on the line. All right? Hope you all understand. Watch over the video. I'm going to end it now. It's been here a while. I don't like when the class on Saturdays go too long. But that is it for today, guys. All right? So watch over the video and redo the questions that you got wrong. If you never do them now. And put this one in the special questions book. This one is a nice special one. All right, put this one in special questions book and do it repeatedly. All right, that is it for today, guys. See you in class tomorrow. Going on to a new topic. Next time, we're still in your programming will be in the revision. All right, that is it for today. All right, guys, but okay?
Yes, sir.
All right, beautiful. I'll send the video into the group right after the class. All right, bye,
Okay,
everybody.
sir.
Have a good day. Bye-bye.
Have a good day, sir.
All right, cool.
Yes. Later, sir.
All right, bye-bye, bye-bye.